Hello, precious students. I welcome you once again to our SHS 2 Core Mathematics program. This program is graciously brought to you by Sendlos. My name is Gershon. We are going to continue our discussion on the topic sequences and series. In our previous lesson, we discussed arithmetic progression. This time, we shall look at geometric progression, the nth term and the sum of the first n terms. So, by the end of this lesson, you should be able to do the following. 1. Recognize a geometric progression, or GP for short. And we also call this exponential sequence. And 2. Find an expression for the general term of a GP. A geometric progression, GP, refers to a sequence in which each term is found from the preceding term by multiplying by a constant factor. This constant factor is called the common ratio, denoted by R. Let me show you some examples. The sequence 3, 9, 27, 81 is a GP with common ratio 3. The common ratio is 3 because we have 9, the second term, divided by 3, the first term, and that is equal to 3. Also, 27 divided by 9 is equal to 3, and 81 divided by 27 is 3. Let's take a look at the second example. The sequence 4, 8, 16, 32 is also a GP with common ratio is equal to 2 because we have 8 divided by 4 is equal to 2, 16 divided by 8 is equal to 2, and 32 divided by 16 is equal to 2. Now, the general term of a geometric progression, say U1, U2, U3 to Un, let this be an exponential sequence with the first term A is equal to 3 and common ratio R is equal to 2. It follows that U1, that is the first term, is 3. Now look at this carefully. U2 is equal to 3 times 2. That's the first term times the common ratio. Then for U3, we have 3 times 2 times 2, which you can also write as 3 times 2 raised to the power 2. Now look at U4. This is 3 times 2 times 2 times 2. And so we can also write this as 3 times 2 raised to the power 3. Look at the order carefully. I hope you have noticed a pattern in the values of U1, U2, U3, and U4. The sequence can be continued as follows. U5 is equal to 3 times 2 raised to the power 4. Look at it carefully. U6 equals to 3 times 2 raised to the power 5. So U7 is equal to 3 times 2 raised to the power 6. U8 is equal to 3 times 2 raised to the power 7. And then U9 is equal to 3 times 2 raised to the power 8. So we say in general, if a GP has first term A and a common ratio R, then the first 4 terms of that GP will be given by U1 is equal to A, U2 is equal to AR, U3 is equal to AR squared, and then U4 is equal to AR cubed. That is, our sequence becomes A, AR, AR squared, AR cubed, and so on. Now, if you look at this carefully, we can see that the nth term of an exponential sequence with first term A and common ratio R is given by UN is equal to AR raised to the power n minus 1. You remember we said U9 is equal to AR, then in this case it's going to be to the power 9 minus 1 is equal to 8. So you have UN is equal to AR raised to the power n minus 1. Beautiful. Now note this for the common ratio. When you want to find the common ratio R, we have the second term U2 divided by the first term U1. And this is the same for U3 divided by U2, and so on, where n is the number of terms. Look at this example carefully. Find the nth term of an exponential sequence of the form 10, 20, 40, 80, and so on. Now, from our sequence, the common ratio R is equal to the second term divided by the first term. And so we have 20 divided by 10, or the third term divided by the second term, which is 40 divided by 20, and that will give you 2. The first term, or the first number, is 10. So using our formula UN is equal to AR to the power n minus 1, the ninth term of this sequence will be U9 is equal to 10 times 2 raised to the power 9 minus 1. And this will give us 10 times 2 raised to the power 8, which is equal to 2,560. Good. The key thing is to get the first term and the common ratio. And then you use the formula UN is equal to AR to the power n minus 1. Let's take a look at this example. Find the 12th term of the GP. 128, 64, 32, and so on. Let's take a look at the solution. What's the first term? 128, that is A. The ratio is 64 divided by 128, which is equal to 1 over 2. Or the same as 32 divided by 64, which is equal to 1 over 2. That is why you call it common ratio. The ratio between these numbers must be the same. We want to find the 12th term, so n is equal to 12. Let's use our formula. UN is equal to AR to the power n minus 1. And then we put A, R, and N to evaluate this. So for the 12th term, we have U12 is equal to 128 times 1 over 2 raised to the power 11. And that will give us 128 times, remember 2 raised to the power 11 is 2,048. So we have 128 times 1 divided by 2,048. And that will give us 1 over 16. Lovely. Sometimes you may be given 2 terms of a GP. And the sequence of this GP can be formed by finding the first term and the common ratio. Let me show you some examples. The second and fourth terms of an exponential sequence GP of positive terms are 9 and 4 respectively. Find A, the common ratio, B, the first term. Let's go through the solution together. Because we are asked to find the first term and the common ratio, let's make A and R be the first term and the common ratio respectively. You remember the general form. The general formula or term of an exponential sequence is given by UN is equal to AR to the power n minus 1. So the second term, U2, is equal to AR raised to the power n minus 1. And so we have U2 is equal to AR, and we are told that the second term is equal to 9. So AR is equal to 9. Let's make this equation 1. Also, we are given that the fourth term is equal to 4. So U4 is equal to AR to the power 3, which is equal to 4. Let's make this equation 2. Now, let's solve the two equations simultaneously. Now, look at the two equations carefully. Here, we cannot subtract or add the two equations. We can do substitution, but the best thing we can do over here is to say equation 2 divided by equation 1. And that will give us AR cubed divided by AR is equal to 4 divided by 9. So we have R squared is equal to 4 divided by 9. We want to find R, so we have to take the square root of 4 divided by 9, and that will give us 2 over 3. Remember, this answer could be 2 over 3 or negative 2 over 3, but we want to find the positive common ratio. That is why we have R is equal to 2 over 3. Now, we are asked to find the first term. Now we've got the common ratio 2 over 3. So let's substitute 2 over 3 into equation 1. And that will give us A times 2 over 3 is equal to 9. What shall we do? Let's multiply through by 3. And that will give us 2A is equal to 9 times 3, which is equal to 27. 2A is equal to 27. We now divide through by 2, and that will give us A is equal to 27 divided by 2, which is equal to 13.5. Beautiful. Now, I want us to look at another thing that we discussed earlier, how to find the sum of a GP or an exponential sequence. The general formula of the sum of the first n terms of an exponential sequence is given by Sn is equal to A multiplying 1 minus R raised to the power n. Then we divide by 1 minus R. It is important to note this, that we use this formula when R is less than 1. That is, the common ratio is less than 1. On the other hand, if R, that is the common ratio, is greater than 1, then the sum of the first n terms is given by Sn is equal to A multiplying R raised to the power n minus 1, all divided by R minus 1. There is a lot of formula to think about, but it's not difficult at all. Remember, we still have to find the first term, the common ratio, and most often these things are given in the question. Let's look at this example. Find the sum of the first 8 terms of the exponential sequence. 1 over 2, 1, 2, 4, and so on. Now, from the sequence in this question, the first term is equal to 1 over 2. And the common ratio is equal to 1 divided by 1 over 2, which is the same as 1 times 2 over 1, and that is equal to 2. And the sum of the first n terms is given by Sn is equal to A in bracket R raised to the power n minus 1, all divided by R minus 1. We are using this formula because R is greater than 1. That is, the ratio is equal to 2. Hence, the sum of the first 8 terms. So we have S8 is equal to half times 2 raised to the power 8 minus 1 divided by 1. that is 2 minus 1. So we have 1 over 2 times 256 minus 1. And that will give us 1 over 2 times 255. And so that is equal to 127.5. Therefore, the sum of the 8th term will give us 127.5. Now let's take an example that involves application of geometric progression. Lucy invested 100,000 Ghana cedis at a compound interest of 8% per annum. Find the value after A, 1 year, B, 2 years, and C, 10 years. Let's go through the solution together. The amount at the end of each year form a geometric progression. We say A, the first term, then the second term will be AR squared, and so on up to AR exponent n. So the first term in this question, A, is 100,000 Ghana cedis. The common ratio R is equal to 1.08. Note that the value of the amount increases by 8%. Therefore, R is equal to 100 plus 8%, and that is 108%, which is the 1.08 for the common ratio. Now for the A part, after 1 year is the second term. AR is equal to 100,000 times 1.08, which is equal to 108,000 Ghana cedis. Then for the B part, after 2 years is the third term, that is AR squared is equal to 100,000 times 1.08 squared. If you work this out correctly, you will get 116,640 Ghana cedis. And finally, the C part. After 10 years is the 11th term, AR raised to the power 10. And so we have 100,000 times 1.08 raised to the power 10, which is equal to 215,890 Ghana cedis. Good. There are so many questions involving application of geometric progression. I advise you to solve more questions in our question banks in your notes too. Well, we have learned that a geometric progression, GP, is a sequence in which each term is found from the preceding term by multiplying by a constant factor. We also said that this constant factor is called the common ratio, denoted by R. For example, the sequence 2, 4, 8, 16 is a GP with a common ratio of 2. We also discussed that the nth term of an exponential sequence with first term A and common ratio R is given by UN is equal to AR raised to the power n minus 1. And finally, the sum of the first n terms of a geometric progression of an exponential sequence with the first term A and common ratio R is given by Sn is equal to A multiplying 1 minus R raised to the power n divided by 1 minus R. That is when R is less than 1. We also said when R is greater than 1, for example, 1.1, 1.02, or 1.523, then we have to use Sn is equal to A multiplying R raised to the power n minus 1 divided by r minus 1. Well, this brings us to the end of our discussions on sequences and series. I hope you have enjoyed it. In our next lesson, we shall look at rigid motion 2 and enlargement. I hope you have learned a lot and you will keep practicing a lot more questions on all that we have been discussing on this program. Join us again for the next lesson. Till then, I say goodbye.